Hi. Okay, I want to help you solve the polynomial x squared plus 14x plus 45 is greater than 0. Okay, when you're solving an inequality like this with x squared, the first thing you want to do is find the boundary points. And to find those, you want to change it to equals instead of greater than or less than. By changing it to equals, just temporarily, we will be able to find the boundary points because they are the solutions to that equation. And make sure it's in standard form, which is what they're talking about in my math lab, of getting 0 on the right side of the equals, just so it's all organized and ready to solve. And in order to solve it, we're going to factor it. So what are the factors? What are the factors that give you a product of 45 but add up to 14? We're going to need x plus 5 and x plus 9. Okay, and then when you set each of those factors equal to 0 to get your solutions, you get x equals -5, or this one would give you x equals -9. Those are called boundary points. Okay, and what they do is they provide markers for you on the number line of your different intervals that will satisfy the inequality. So what you want to do is you want to now draw a number line and put those boundary points on it. -9, -5. Okay. And we're going to have to now test in between the boundary points to see which intervals on the number line actually satisfy the original inequality that we were given in the problem. And so we're going to use what are called test points. Now we want to test a number in each interval. So for example, over here in the numbers less than -9, we want to plug in some number for x that's less than -9. So maybe we could test x equals -10, for example. And the way we test it to see if it works is we plug it into the original problem. Okay, so when I plug in -10 into the original, I get is -10 squared plus 14 times -10 plus 45. Is that greater than 0? And when we evaluate that, we get 100 minus 140 plus 45. So what does that give us? Let's see. It gives us 5. Is 5 greater than 0? That is true, okay? So that means you want to shade that part of the number line since it came out true, okay? So you'll go like this, shade. Okay. Now, you're going to have to test a number in each interval because it's possible that the next interval could also be true or it might be false. So some number between -9 and -5 in here. What could I test between those numbers? Well, I guess I could test -7. Okay, so let's test -7 together as well. When I put it into the problem, is -7 squared plus 14 times -7 plus 45. Is that greater than 0? If you work out all these numbers over here, you're going to get 49, 45. Oh, you're going to get a false. Okay, I'll let you work that out on your own with a calculator if you like. So that means don't shade the region between -9 and -5. And I won't show you the work, but you'd also have to test one more time in this interval here between -5 and infinity. Maybe plug in -6 or -4 would work, or 0, something like that. And it should come out true, I believe, on this one. So we're going to go ahead and therefore shade that region. Okay. Oh, different color. My mistake. Okay. And then what we want to do at this point is decide about parentheses or brackets on the shading. And because the original problem was just greater than, it's not or equal to, that means that we're going to use parentheses, okay? So it's going to look like this. My parentheses aren't coming out here. There we go. And on this side as well. Okay. And then the last thing would be to write your interval notation for those regions. So everything from negative infinity to negative 9 is shaded in that first segment. And then you want to put a U because there's a little gap. And then everything from negative 5 to infinity is shaded in the second segment. So that'd be your interval notation and a final answer as well. I hope that makes more sense, but let me know if not. I'm happy to help. Bye.
Made with Doodlecast Pro.